In today's video, we're going to talk about how we can connect different devices together. In our last video, we saw how we can register for Cisco Packet Tracer, and we downloaded Cisco Packet Tracer. And in today's video, we will be using the Cisco Packet Tracer to connect different devices together. But before doing that, we need to know how we can connect different devices based on which type of cable will be used there. And there are basically two types of cables: a straight through cable and a crossover cable. As you can see from the image here, a straight through cable is pretty simple enough. These 1, 2, 3, 4, 5, 6, 7, 8, these are the actually uh, uh, wires that are present in a network cable. Okay, there are basically 4 pairs, and each pair contains a white, you can say a striped color, and a full color. And for example, this one, and the first one is white, green, and green, and so on. So when we are making a straight through cable, each pin, for example wire 1, connects to the other end on wire 1. Okay, how it connects? We use a connector called an RJ45 connector. These connectors are used on both ends. So these numbering that you see here, these are actually these pins that you can see on these connectors, these copper pins. So when we arrange our wires according to different standards that are internationally recognized, when we arrange these wires and we place them in these connectors with the help of a tool that is called a crimping tool, just like you see here, we punch these wires in these connectors. Okay, so what happens is, on both sides, these uh, pins are actually representing these pins that are present in the RJ45 connector. So if on both sides the combination is same, for example, pin 1 is connected to pin 1 on the other side, and pin 2 is connected to pin 2 on the other side, so that will make a straight through cable. But if we switch it through, we make a cross. Actually, out of these 8 wires or 8 pins, only 4 are being used for transmission and receiving. And specifically 1, 2, and 3, and 6, these are the pins that are mostly used. So if we cross these up, for example, if we interchange 1 and 3, if you see in the crossover cable section, so if you on one side the pins are same, 1, 2, 3, so on to 8, but on the other side the pins are crossed. 1 and 3 are exchanged, and 2 and 6 are exchanged. So if you can see from the image here, it makes a cross. So on the basis of this cross, that's why it's called crossover cable, physically and also the data connection. The reason for that is, as you know, if you connect different devices together, for example this one and this one, suppose this is a one-way traffic road. This is a one-way road. Traffic can only go from one side, not the other side. So if we can connect the devices in such a manner, and the traffic is coming from both ends, so it will collide. These actually depend on the type of the different types of the devices that we use to connect each other. So after this, we will talk about what kind of devices will use a crossover cable, and what kind will use a straight through cable. So these are actually according to the different devices and different receiving and sending patterns that are available in that certain device. So simply put, if you connect the same end with the same end, then you will get a straight through cable. But if you cross the cable, for example, if you switch on one end, it's same, but on the other hand, you change 1 and 3 and 2 and 6, the position of 1 and 3 and 2 and 6, you will get a crossover cable. Okay, so next, if you see, these are the different devices that can be connected. These are most common devices. And we will also try to connect these devices in our today's video in Cisco Packet Tracer. This device symbol is a router, and this is a switch. This is, as you know, an endpoint device. This is a server or same endpoint device. This is a hub. Okay, so the principle that you need to keep in mind as there are basically two kind of families. Switch and hub belong to one family, and all the other devices like the endpoint devices, routers, APs, etc. These all belong to the second class of the or the second family of the devices. So whenever we are trying to connect two devices that are in different family, that is interfamily connection, so we will use a straight through cable, because the pin pattern in both of them are made in such a manner that these kind of pattern will be used, because one will be sending and the other will be receiving and the same, and uh, there will be no collision. But on the other hand, if we're going to use a cable to connect two similar devices, okay, so when we are going to connect two similar devices, or when we are going to use to connect two devices that are in the same family, then we are going to use a crossover cable. Okay, so once again, if you are using or making a connection uh, between different family of devices, then you are going to use a straight through cable. But if you are connecting the device with itself or within the same family of devices, then you are going to use a crossover cable. And these are the different examples uh, of straight through cable and crossover cable, and we're also going to try to make them. So let's switch to Cisco Packet Tracer and try to make those connections. So for example, if we are going to connect a PC and a router, for example, any router, okay, so we go to connections, and here we can find a copper straight through cable and a copper crossover cable. So since these two belong to the same family of devices, so we will use a copper crossover. And the process in packet tracer is you will connect or click on any of the two devices, whichever you want first. Just click on it and then select a port. And as you might know, the ports that are available uh, in any device, for example, in a PC, is mostly coming from a network adapter or a NIC card or a LAN adapter or a LAN card. And in other devices like routers and switches, there are different modules installed, and these are mostly signified by fast Ethernet or gigabit Ethernet, or in older ones only Ethernet. So from here we are going to connect it to fast Ethernet. Fast Ethernet, it means that we can go up to speeds of 100 MBs per second, and gigabit, as you know, the name signifies you can go up to 1 gigabit per second, and depending on the device, more than that. So let's connect on the second one. So we will click on the second device and then click on it, and here it only gives gigabit, so we will connect it. Right now it doesn't show any connection. In Cisco Packet Tracer, these small triangles that you see here, they signify the connection establishment. So if they are red, it means there isn't a successful connection. And now it might be due to different reasons, but the first would be the most common, that the type of the wire that we use is not correct. But here actually the type is correct, but there is and other reason here because we're connecting to a Cisco router. And if you hover your mouse on the router, you can see the definition that the link gigabit Ethernet 000 is down, and that's because every port in a Cisco router is administratively shut down. So before we're going to use it, we need to up the link. This will be covered in more detail in our later videos, but right now I'm just going to up the link and let's see what we can do here. So let's enable it, and I'm going to so to the configuration commands I have uh, lifted the shutdown command, and as soon as I did that, you can see that the link is up. But at the same time, if we are going to repeat this process, we connect this router and we use a straight through cable. Now connect fast Ethernet and that the gigabit Ethernet. Now the process will be same. Since it's administratively down, I will have to issue some commands, uh, which, as again I said, we will discuss in detail later on. Let's up the link. So as we saw earlier, we said that only crossover cable will be used to connect uh, the devices that are in the same family. But here we use a straight through cable, but it also connected to the router. So this will violate our theory. So let's test it out again. For example, if we are using an older router and then connecting it to the router, and then as already understood, we are going to have to give some commands. So the link is up, but still it doesn't work. So what I wanted to show us that in modern routers, upgraded versions, these kind of principles might not hold. So it doesn't mean that a cable, a straight through cable, cannot be connected, but it will depend on the type of the router or on the type of the device that we are using to connect. So traditionally, this will be the rule, because if we're using an older router, if we connect a straight through cable, it will not connect. But if we're using a modern router, a newer router version, then it can connect. So if we're going to avoid any uh, rule violations, or if we are going to avoid any problems later on, we should just stick to the rule that whenever we are going to use connect different uh, devices that are in the same family, whenever we are used to connect two devices together, for example this one, for example a PC to a PC, okay, so we will use a crossover cable. And in this example also, for example, if I put two more PCs on and I use a straight through cable, it will not connect. Okay, so we should remember the principle that whenever we are connecting two devices together, same devices together, are we connecting two devices that are in the same family together. And this type of situation also occurs in a switch. For example, If we're connecting a PC and switch, for example, this one. Okay, let's see. No, first let's take this one. For example, so we will, by the rules which we have studied, we will have to use a straightthrough cable. Okay, so let's connect it, and within a few seconds, this link will hopefully go up. But if we go to the switch and then again pick the switch and we change the cable, for example, crossover cable, let's see what happens. As you can see, the connection is not established. The upper link, it's established, but here it's not established. But again, if we connect a PC with a switch of a new model, let's see what happens. Traditionally, this failed. Obviously, this one worked, so it will work. So let's try with this one to see if the cross cable works on this switch. And if we connect that, you will see that it will also connect. So in modern devices or the modern network devices like switches or routers, any type of cable can work because they contain an intelligent chip that automatically uh, adjusts its pin according to whichever cable it is connected with. So then again, if we are going to avoid any issues later on, there might be wrong cable and other things. So if we're going to avoid those issues, we should just stick to the basic principle that whenever we are going to connect two same devices or two devices that are present in the same family, we are going to use a crossover cable. And whenever we are going to connect two different family of devices, and as you know, there are only two devices in one family, that is switch and then hub, and the all other are in the other family. So I think that it's pretty simple to keep that in mind. So for example, let's do another example. If we want to connect two switches together, so what will be the type? These are in the same family. The two simple same devices are being connected. So cross connect one and cross connect one, and this is a cross cable, it will be connected. Okay, again, for example, let's take another example. Let's go to network devices, and if we connect two routers together, it will also be a cross cable. Okay, of course we will have to give the commands to get those links up that are administratively down. So once the CLI gets booted, okay, I will issue the commands. One side is up, so let's do the other side. And as soon as the both ends are up, you can see our link is also up. Okay, so I hope that you understand the basic principles of how we can connect different devices together in Cisco Packet Tracer, and also the same principle applies on real devices or physical devices. So the thing that we need to make sure is whenever we are connecting two same devices or two devices that are present in the same family together, we're going to use a crossover cable. Whenever you are going to connect two devices that are in different family, that is an interfamily connection, then we are going to use a straight cable. And the families are switch and hub belong to one family, and all the other devices like the end devices, routers, APs, etc., they all belong to the second family. So I hope that you can understand the concept from here, and I'll see you in our next video. Take care.